Hello students, I hope that you are good, well and fine. In today's session, we will be seeing integration by using partial fraction method. Okay, so let's see that what we are going to uh, learn about. So rational function and partial function. Okay, then we will be directly jumping to NCERT exercise 7.5. Okay, which is related to partial fractions. Okay, from the exercise you will get to know that how we are applying our approach. So rational function is just nothing but if the degree of polynomial of px is less than the degree of qx, then the rational function is called proper, otherwise it is called improper. The improper rational function can be reduced to proper rational function by long division process. Okay, now some of the ways to apply in partial fractions. So this is what if you see your rational function as in this form. So px plus q divided by x minus a x minus b. So this can be rewritten as in the form of a by x minus a plus b by x minus b. Okay, if you see this px plus q divided by x minus a whole square, then try to reduce in this form a by x minus a plus b by x minus a whole square. If you see this px square plus qx plus r divided by x minus a x minus b x minus c, then reduce it in the form a minus x minus a b minus b divided by x minus b c divided by x minus c. If you see this px square plus qx plus r divided by x minus a square x minus b, this can be reduced to x minus a plus b by x minus a square plus c by x minus b. Now px square plus qx plus r, this form divided by x minus a multiply with x square plus bx plus c, this whole form can be reduced to a by x minus a plus bx plus c divided by x square plus bx plus c form. Okay, you have to perform such sort of transformations, okay, variations in order to deal with partial fractions. Okay, so whenever you have such sort of expression in integrand, okay, you will have to apply the corresponding thing. So let's see. Now let's jump to our questions, exercise 7.5. Now the first question says, let me just quickly show you the first question. So the first question says integrate this expression. As you can see this form, this is some linear form divided by some linear form multiply linear form, this means. Okay, so break it into a by x plus 1 plus b by x plus 2 form and put it equals to 0. Okay, so x is equals to, so this whole term will be equals to something like this. Okay, now what? Now after taking the LCM, this or after simplifying this, you will get a times x minus 2 b times x minus x plus 1. Okay, sorry, a times x plus 2 b times x plus 1, but this will be equals to just x. Okay, and now you will have, now distribute things and compare the x coefficient to the x coefficient and constant terms to the constant terms. You will get what? You will have ax plus bx, this means a plus b must be 1 and 2a plus b must be 0. So if a plus b is 1 and 2a plus b is 0, then subtract it, you will get what? A is equals to minus 1. So a value will be minus 1. If a is minus 1, then b must be 2. Okay, you will have a minus 1, b 2. Now what you have to do? Now replace your a b here. Now replace your a and b values. You will get what expression? You will get this thing. Okay, this thing, you will get this whole expression changed to this expression. Okay, clear? So this will be integration of this expression now is integration of minus 1 by x plus 1 plus 2x plus 1 x plus 2. Now separate them and you know the direct integral for them. You will have minus of log modulus x plus 1 plus 2 log modulus of x plus 2 plus some constant. Okay, simple. Now simplifying this using the logarithmic properties, you will get directly, I will be using directly, so it will be log modulus x plus 2 whole square divided by x plus 1 plus some constant. Okay, clear? I hope it is clear to you. So let us move to the next problem. Now 1 by x square minus 9 can be reduced to 1 by x minus 3 x plus 3. Okay, like this. And this form we know from the just we saw it that whenever you see such sort of expression, you have to break it into a plus x plus 3 plus b divided by x minus 3. Okay, now simplify it. You will get 1 is equals to a times x minus 3 plus b x plus 3. Okay, now what? Now comparing the things, coefficients, you will have a plus b is equals to 0 and minus 3a and plus 3a is equals to 1. So this means it will be a okay, this will be what? As you can see now, your answer will be what? B will be 1 by 6 and a will be minus 1 by 6. Very easy to solve them. Why? Because you are having two unknowns with two equations. So two unknowns, two equation can be easily evaluated, and you will get what as your a as minus 1 by 6, and what will be your b your 1 by 6, positive 1 by 6. Okay, now your original expression 1 by x plus 3 multiply x minus 3 is now can be rewritten as in this form 1 minus 1 by 6 multiply x plus 3, okay, plus 1 by 6 x minus 3. Simple. Now your integration is now changed to this form, and you know you can use the result from the integration. Okay, that integration of this part plus integration of this part will give you the answer for the whole part. Okay, clear? Now what this means? This means that integration of this will be minus 1 by 6 log x plus 3 modulus and plus log 1 by 6 log modulus x minus 3. This thing. Okay, clear? Okay. Now using the what? Logarithmic properties and also taking this 1 by 6 common, you will have log of x modulus x minus 3 divided by x plus 3 plus some constant c. So your final answer will be this. Okay, I hope it is clear to you. So what we are using again and again, we are using just nothing but the form we are given with, we choose the corresponding or the respective transformation. That's it. Okay, clear? Let us move to the problem number 3. So third problem says this. Now break it into the respective form. So that the respective form will be a by this thing, b by this thing, and c by this thing, and then simplify it and compare the thing. So after simplifying, you will get 3x minus 1 is equals to a times x minus 2 x minus 3 plus b times x minus 1 x minus 2 plus c times x minus 1 x minus 2. Okay, clear? Okay. Now again, after product and comparing things, what you will get? You will get a as 1, okay, b as minus 5, okay, and c as 4. Okay, the one thing is to first simplify it, expand it. Okay, okay, or another way to find your a b c value will be very easy. Make some of the terms equal to 0. This will vanish your other terms and will give you the value you want. Suppose if you substitute x is equals to 1, if you substitute x is equals to 1, then what you will have? So this will be 2. 2 is equals to this term will be 0, this term will be 0. From here what you will have? 2 is equals to minus a. Yes, 2 is equals to what you, sorry, 2 is equals to, if you put minus, sorry, x is equals to 1, this will be minus 1 and this will be minus 2. Minus 1 minus 2, this will give you 2a. 2a is equals to 2, this means a is equals to just 1. The same thing will happen if you put x is equals to 2, you will get b value, x is equals to 3, then you will get c value as minus 5 and 4 respectively. Okay, simple. So here you do not have to simplify it further. You can reduce that work. Okay. So let us move next. Now the a value is now 1, b minus 5 and c 4. Now substitute back your, this expression will be what? This 1 by x minus 1 minus 5 by x plus x minus 2 and plus 4 by x minus 3. Okay. Now this means your integration is now uh, transform into this integration. After separating them, you can have log of modulus x minus 1 minus 5 times of log modulus x minus 2 plus 4 times log modulus x minus 3. Okay, if you want to use the log property, you can use, otherwise you can leave your answer to here. Okay, clear? Let us move next. Now the fourth solution for the fourth will be, now same thing we will be applying. So a by x minus 1 plus b by x minus 2 plus c by x minus 3. Okay. From here, what you will get now, x will be a times x minus 2 x minus 3 plus b times x minus 1 x minus 3 plus c times x minus 1 x minus 2. Now substituting some values for a such that you will get your a, b, c values. So substitute x is equals to 1, you will get a value. Substitute b is equals to, x is equals to 2, you will get b value, and substituting x is equals to 3, you will get c value. Okay, so their respective values will be what? A is equals to half, as you can see, b is equals to minus 2, c is equals to 3, 3 by 2. Simple, very easy to find now. So now your expression, your function, rational function is now transformed to this expression. Okay, so from this you can get your integration of the original thing is equals to integration of 1 by 2 x minus 1 minus 2 by x minus 2 plus 3 by 2x minus 3. Okay, so now separating them or evaluating the integral separately, you will get half of log x minus 1 minus 2 log x minus 2 plus 3 by 2 log x minus 3 as this your answer. Okay, clear? I hope it is clear. Let us move to the fifth problem. Fifth problem says 2x divided by x square plus 3 plus 2. Now this simple thing, what you have to do, that break it into this parts, two different fractions, partial fractions. You will have simplified thing as 2x is equals to a times x plus 2 plus b times x plus 1. Putting x is equals to minus 1, you will have a value. Okay, if you put x is equals to minus 1, this will be minus a, and just compare it. So you will have minus 2 is equals to minus a. This means a is equals to, sorry, this will be a is equals to minus 2. So just a is equals to minus 2, and putting x is equals to minus 1. So x is equals to minus 1, sorry, minus 2. Minus 2 means x is equals to minus 2 means minus b is equals to minus 4. This means b is equals to 4. Okay, you will have these two values. Okay, one for a and one for b. A is equals to minus 2, b is equals to 4. Okay, this means your expression will be now what? 2x divided by x plus 1 x plus 2 is now changed to partial fraction as minus 2 divided by x plus 1 plus 4 divided by x plus 2. This means this integration can be rewritten as this integration of 4 divided by x plus 2 minus 2 divided by x plus 1 dx. After evaluating the integrations separately, you will get 4 times log modulus x plus 2 minus 2 log modulus x plus 1 plus some constant. Okay, clear? Let us move next. Sixth problem. Now sixth problem says 1 minus x square divided by x multiply 1 minus 2x. Simple. So this means, as you can see, it can be seen that given integrand is not a proper fraction. Therefore, on dividing 1 minus x square by x 1 minus 2x, we obtain what? So this means, first of all, we have to reduce it in proper fraction. So in order to reduce it, you will have just do the long division. You will get half plus half of 2 minus x divided by x 1 minus 2x. This thing. Okay. Okay. Whenever you are not given with a proper function, then you have to always divide. Okay. Then you will get your proper function. So now your expression is reduced to proper function. Now what you can do is quite simple. This expression, now we have to break it into partial fractions as in this form. Okay, so you will have 2 minus x is equals to a times of 1 minus 2x plus some bx. Clear? Okay, now substitute x is equals to 0. You will have a is equals to 2 and substitute x is equals to half. You will have b is equals to 3. Simple? Clear? Very easy to find these a and b values now. Okay. This means 2 minus x divided by x 1 minus 2x can be rewritten as 2 by x plus 3 by 1 minus 2x in this form. Okay. Now substituting the things, you will get your original expression was 1 minus x square divided by x multiply 1 minus 2x. This can be, we further reduce it in this form. Okay. And then the final form for this expression will be half plus half of 2 half multiply with, okay, so here must be the brackets. Okay, as you can see, half multiply with 2x plus 2 by x plus 3 divided by 1 minus 2x. Okay, so your integration will be now what? Integration of half plus half of 2 by x plus 3 by 1 minus 2x dx. Okay, you know the direct integration for this will be x by 2. Integration for this, direct integration for this will be just log of modulus x, and for this will be 3 log 1 minus 6. It will be what? Just nothing but a 3. So after multiplying with half, you will get 3 by 2. Okay, so 3 by 2 log 1 minus 2x, and also for this it will be minus 2. So you will have the final form as this. Okay, after simplifying, after multiplication, you will get this as your answer. Okay, I hope it is clear to you. Simple. Okay, let us move to the seventh problem. Now seventh problem says integrate x by x square plus 1 multiply x minus 1, the same. So how can we reduce it? Quite simple. X. Okay, so this can be reduced at its corresponding form, which is ax plus b divided by x square plus 1 plus c by x minus 1. Simple. So you must know the corresponding form. If you do not remember, please uh, watch this session from the beginning. Okay, then you will have here, now come to the solution. So here you will have x is equals to ax plus b multiply with x minus 1 plus c multiply x square plus 1. Okay, now multiplying what you will have this as your simplified expression. Now comparing things, you will get what? You will have, sorry, Comparing things, you will have comparing x square coefficient, you will have a plus c is equals to 0. Okay, comparing x coefficient, you will have b minus a is equals to 1, and constant term, from the constant term you will have c minus b is equals to 0. C minus b is equals to 0. You have three unknowns and three equations. This means you can easily solve it. Okay, how you are going to solve it? Very easy. Add first two equation, what you will get, c plus b is equals to 1. Now add this, what you will get. Okay, so or you can see that add all of the equations, you will have that this will be cancelled, b will be cancelled, you only left with 2c is equals to 1. This means c will be half. Okay, c value will be half. So c value will be half. If you know c value, this means a will be minus half. A will be minus half. If a value you know, this means b, or from this you can say c will be b will be just nothing but equal to c. Okay, clear? I hope it is clear. Let us move next. So from this, what you can say is your expression now reduced to this form. Okay, now you will have minus of integration x by x square plus 1 dx plus half of integration 1 by x square plus 1 dx plus half of integration 1 by x minus 1 dx. Okay, this integration, okay, we will be evaluating later after substitution, but we know the integration for this directly. This will be in form of tan inverse, so half of tan inverse x. This integration we can directly know half of log modulus x minus 1. Now the integration for this will be, okay, evaluated by using substitution, and we will be using the substitution what taking denominator thing equals to t. As you can see, this will give you 2x dx is equals to dt. This means integration of 2x divided by x square plus 1 dx is equals to integration of dt by t. This means log modulus t. This means log modulus x square plus 1 t plus 1. And from here, what you can say, integration of this whole thing, the original thing can be answered by this expression. Okay, if you simplify it further, you will have this, or rearrange some terms, you will have the original answer as like this. Okay, if you are getting some another form, don't worry. Okay, the form will be the variation, another variation for this expression. I hope it is clear to you. Now as we have seen problem number 1 to 7 solution. So in this session, in today's session, we will be discussing only these problems. Okay, the remaining problem we will be seeing their solutions in the upcoming session. Okay, so for now, I hope that you understood how we applied our theory, our concept of partial fraction. Okay, so we have two cases. One is proper function, another is improper fraction. Proper fraction and improper fraction. Okay, so whenever you are not given with proper fraction, then reduce it into proper fraction. This will gives you what? Your freedom, gives you liberty to use the partial fraction form, their corresponding form. Okay, from which you can directly evaluate your integrals. Okay, so for now, this is it. So thank you all. We'll be back with more problems.